Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the Coding Geometry Dash in Java series. So in the last tutorial, what we got to was we now have fully working triangle collision detection. So we can detect whether the player is intersecting with the triangle, which allows us to kill the player if he touches any triangles. In this tutorial, what we're going to be doing is starting to implement some of the final features. You can take a moment and pat yourself on the back if you've reached it this far and you have followed this tutorial and you have coded all this. We now have a fully featured game that is basically done. The only thing that we have to do gameplay wise is just state changes. You could build a fully featured level now with what we have right here. So this will just make our lives a little bit easier while we're building the levels by enabling some level editing features such as selecting objects in edit mode, moving those objects while in edit mode, doing multi-select, box select, all these different things, which we will be coding by hand. It's a really cool little venture into UI work and how all that stuff works. And you get to learn just a little bit about this stuff. So I hope you guys enjoy this tutorial. Let's get started and see how we're going to do all this. Alright guys, so like I was saying, we got to the point where we now have fully functioning triangle collision detection in the last tutorial. And now what we're going to be doing is adding in some level editor stuff so that we can go and say we have a level loaded, we can click on these, select them, move them around, all that stuff. We're not going to be moving anything, we're just going to be working on multi-select right now because it is quite a large function and it takes a little bit of time to get working. The first thing that we're going to have to do is create a few utility functions that we should have created a very long time ago. Let's go into our scene class or our window class because this is where we're going to be working on our first one. We're just going to create a couple utility functions that will make life so much easier. This is going to return a scene and we're just going to call it getScene. So instead of having to do the getWindow then getScene, we can just say window.getScene, which is really how it should have been. And this will just return getWindow.getScene, current scene. Very simple. It's just a wrapper, and if the compiler's any good, we don't have to worry about this bottlenecking anything because of the overhead of a function call, because it will inline this or something like that. I don't think Java really does that though. In C++, you would get more optimization out of stuff like this, whereas in Java, I think it will get a little bit more overhead because of the function call. But that's fine for us. We don't really care. Next one we're going to be doing is a ML for a mouse listener, and we're just going to call this mouse listener so that we can get to that very easily as well. We'll just return getWindow.mouseListener. And lastly, we will create a static KL for key listener, and this is just going to return getWindow.keyListener. So just a couple simple wrappers. These will be tremendously helpful in what we're going to be doing. And then next, let's go into our scene, and we are going to add in one more utility function that will be helpful to us. This is going to be called, it's going to return, first of all, a list of game objects, and it's going to be called getAllGameObjects. And as you can expect, it's going to return the game objects list. This is just so that we can get all the game objects inside of our components script that is going to be controlling all the level editor controls. Next thing I think would be good to do, let's go into component. We are going to be re-transforming snap to grid a little bit. Instead of being snap to grid, I'm going to right click, and if you hit refactor, rename, we're going to name this level editor controls. And then if you hit refactor, it's going to say, hey, we have a local variable named snap to grid. Do we want to rename it to level editor controls? I'm going to check that and say yes, because that would be good. And this has successfully refactored it. Now it's level editor controls, because this is going to be more apt for what this will do. This is going to be in charge of all the level editor controls, in charge of snapping to the grid and everything, just all that different stuff. Let's create a couple functions that are going to be helpful for us because we want to start abstracting. This update function is getting very cluttered, and we want to abstract as much of that away as possible into the functions. That way it's very clean and we know exactly what's happening at each step. So first one we're going to have is something called update sprite position, and this is going to do exactly what you expect. If there is something being held in the mouth, a sprite, then this function will update that sprite position, which is all the logic placed right inside here. And then we're going to actually add in a couple more private variables up here because we need to keep track of this guy's world X position and world Y position, and it's easier to do it this way than it is to just do this. So change this X to a this.worldX, and then this Y to a this.worldY, and then just copy this, place it here, copy this, place it here. And this is just going to help us out a little bit more. Now we can say, instead of doing all this garbage, update sprite position. That's one thing. That's one less cluttered thing we have in here now. Next thing we want to do is, what is this doing? Well, this is just placing a game object into the scene. So we'll just create another function called public void place game object. Or let's call it copy game object to scene, because that's really what's happening there. And the more explicit we are with these functions, the easier it will be for us when we're looking back at this in a future date and trying to add things, do whatever you want to do with this. Change this to world X, change this to world Y, since we abstracted those away, and that should be good. And then we can just go down here and say copy game object to scene. Leave the debounce left here, because this is just our little indicator that, hey, whoops, down here is, hey, mouse has been clicked. And then we can do more stuff inside here too once we get to that. So that's enough abstraction in here for now. We're going to add more to this, but first we should add some functionality so that we can select objects on the scene. How do we know if we're trying to select an object? Well, we know we're trying to select an object if I'm clicking. I'm not holding anything, so there's nothing in my mouse, there's none of these blocks in there, and I'm clicking and I'm just clicking onto one of the objects. Well, how do we know if I've hit one of those objects? Well, if I click into here, we have to check that point in the world and see if that point lies within this triangle. If I click right here, we have to check within the world, see if that checkpoint lies within the rectangle, the square. We're lucky. All these things have box bounds and triangle bounds associated with them. So we can just add a simple function to our bounds class called Raycast, which takes in a vector 2, the position of the mouse, and determines, it will return, hey, this is inside of the item, or no, this is not inside the item. So let's create that function real quick inside our bounds class. We'll go up here. We're going to make it abstract because each functionality will be different for the different types of bounds. And this will just return a Boolean, and it will be called Raycast and take in a vector 2 position. So I call it Raycast. This isn't really a Raycast. A Raycast in functionality is a lot different than the way we're going to implement this. You're actually marching a ray into the scene, whereas what we're doing here is just checking whether this point is within some bounds. But essentially what we're doing is a Raycast. We're just checking to see if this point is inside something. We're checking to see if this point hit something. And that's sort of what we're doing. Let's go into box bounds and implement this now. Going to complain because we do not have that method implemented. Doing box bounds first, because really easy to check whether points inside a box. You just say, is the position.x greater than this .gameObject.transform.position.x, and position.x is less than transform position x plus this .width, and position.y is greater than this .gameObject transform position.y, and position.y is less than this .gameObject.transform.position.y plus this .height. That's all you have to do. Position being the mouse position, we're checking to see if this x is greater than the left side, it's less than the right side, and it's greater than the bottom of the box, and it's less than the top of the box. That's all we're doing. Very simple. Triangle bounds, a little bit more complicated. We're gonna not implement that just yet, and I'm not actually even gonna go over how the final method we're gonna use works. I'm gonna leave a link because I don't even fully understand it. It uses some fancy math. We're just gonna return false for now. But we'll get around to that once we get around to that. Actually, let's go back into bounds and let's add one more variable up here. This could be public Boolean is selected. And this is just going to tell us whether this game object is currently selected. Let's go back into box bounds and add in a public void draw graphics 2D G2. And then we're just going to add in a simple thing. If it's selected, then we want to draw something. Let's go into constants real quick too, because what I'm going to want to do is set the stroke to something called a thick line, and then we're going to draw the lines for the box, which is very simple. We'll just say draw new rectangle 2D dot float, and then this will just take in this dot game object dot transform dot position dot x minus the camera x, which we will do in a second, and then this dot game out transform position dot y, and this dot width, and this dot height. Important that we do minus the camera x, because right now these our world coordinates, not screen coordinates. We want to make sure we have these on screen coordinates. So we'll say window.getScene.camera.position.x. We will subtract that from the x, and we'll subtract the camera's position in the y. This should be getScene. .getScene.camera.position.y. This transforms it to screen coordinates instead of world coordinates, so that we are drawing this green rectangle. Let's set the color to color.green around the box if it's selected, which will just sort of act as our indicator, hey, this box is currently selected. And then we'll just set the stroke back to constants.line, which is just the regular line. Let's go into constants, create those two strokes real quick, and then we'll see how all this works in actuality once we implement the raycasting. So we'll go into util constants, and then right at the bottom here, I am going to add in a public static final stroke. This is going to be our line, which is just be a new basic stroke 1.0f, which means we have a 1 pixel wide stroke, public static final stroke, thick line, which I'm just going to make 2 pixels wide. You can change it to whatever you want. I don't care. Okay, and then we will go back into our box bounds, make sure that is cleared up all the errors. That's good. Now we need to implement it so that when the player clicks in the level editor controls, it picks up, hey, they're clicking and they're trying to select an object. So if we go back into here, how do we tell if we're editing or if we're not editing? Well, let's actually add in another Boolean up here that says private Boolean is editing. And we're going to initialize this to false. Next, what we're going to do is we're going to have an if statement here. If this.gameObject.getComponent sprite.class does not equal null, then we're going to set this.isEditing to true. And then we're actually going to go up here. We're going to say if it's not editing and this. That way, if we are editing, we already know we have the sprite component attached. And so this little thing will just make sure that it drops out before going through this function, which could take up a little bit of time. In actuality, it doesn't matter too much because our level editor doesn't have to be as fast as our game since it's not running on frame by frame basis. It's more, this would just bottleneck it every few frames, which is fine for a level editor. It's not fine for the actual game though. Then what we're gonna do is we're gonna say if is editing update sprite position. We do want to do that every frame if it is editing. Let's take this out, delete that, and then let's move this back a little bit. This just tells us whether the mouse has been clicked or not. So if the mouse has been clicked, what we want to do is say, if we are editing, then we want to copy a game object to the scene. There's a couple different things that we're going to do. We're going to have it set if you're holding down shift and you click, then it's going to multi-select, just like this works with like clicking things. Typically, if you're holding shift, then you can add things and it won't take away things. And that's what we're going to be doing. And if they just click, then we're going to have it switch from one object to the next. So let's do else if the key listener, so window.keyListener.isKeyPressed, and then I'm going to go key event.vk shift. So if the key listener is pressed and they just clicked, if shift is pressed and they just clicked, then we want to add game object to selected. And then we will pass in a new vector2 with the mouse listener's X and the mouse listener's Y. And let's go up here. We're going to need another variable up here. Let's just call this private list of game objects. And this is going to be selected objects. This will contain all objects currently selected. Inside here, we will initialize this to an empty array list. And then for our function, let's copy that and implement it real quick. Public void add game object to selected takes in a vector2 mouse pose. And first of all, we want to transform that mouse position to screen coordinates. So we will add in the camera's position. So the camera's X and the camera's Y, because right now that is in screen coordinates and we want to transform it to world coordinates. Simple as doing that. Then once it's transformed to world coordinates, what we want to do is we want to add in a new object. We want to check and see if this actually hit anything. So what we'll do is we'll say for game object, go in window.getScene.get all game objects, that function we just implemented. We're going to loop through all the game objects and check and see if this vector hit any of them. we'll say bounds equals go.getComponent bounds.class if bounds does not equal null, and bounds.raycast this mouse pose. So if it's not null and they raycast it, then we will say selected objects.add this game object. We will say this game object, or actually this bounds dot is selected is true, and then we will break from this loop because we just returned the very first one that we hit. So now if they're holding shift and they hit it, it should do this. What we're going to do is also add in that last functionality, which is if they're not holding shift and they click, we want to clear selected objects and add, and we're going to add in this new vector2. Same thing here. I'm just going to copy that. So this is another function we're going to add, and this is going to basically make us that just switches whatever object they're currently selecting. So let's add in that too. Public void clear selected objects and add vector2 mouse pose. And what we're going to do is we're just going to say for game object go in selected objects. We know each of these is going to have a bounds component attached to it because there's no way that it could and get added to this because we're checking for that right here when we add it. So we're going to say get bounds.class is selected equals false. So we just make all those false, and then we say selected objects.clear, which just clears our list of all those objects, and then we'll just say add game object to selected mouse pose and call that function. This will clear everything and officially reset it. Let's check and see if this is working. So it should be working for boxes. So if I go in and throw in a couple of boxes in here, this is sort of our first problem. So I'm going to save this real quick, and then let's load it back in. Just hit F2. And if I click one, first of all, that's clearly not the right place, but it is selecting them. And if you hold shift, it selects multi. So we gotta see what's going on with that. Why is it drawing them in the wrong place? And the reason it's drawing it in the wrong place is because by the time draw is getting called here, I forgot about this, our render has already transformed the game object to the appropriate position. So we don't have to worry about the world coordinates there. We should be able to just leave that. And if we redo this, you can see it's working fine. And we can select them, multi-select if you hold down shift, and then just change it if you just click on the different ones. Triangles don't work right now, and also we have this problem. If we start editing, there's no way for me to escape this. So we want to bind our escape key to escape from editing. Let's go down here, and we'll simply add in if window.keyListener.isKeyPressed key event.vk escape this functionality into a function called escape key pressed. So we'll do that, and we'll go up here and say public void escape key pressed and implement all that logic up here. And it's literally just going to be, we're going to create a new game object. So we're going to say new game obj equals new game object. It's going to be called mouse cursor. It's going to take in this .gameObject.transform.copy, and then it's going to take in this .gameObject.zIndex. So it's basically going to be copying this, and then we're going to say add this component, literally this. We don't care if it's a reference because we just want to keep the same reference that we already have anyways. And then what we're going to do is we're going to get a hold of our level editor scene, and we're going to say it equals our level editor scene window.getScene. So we cast it, and then we are going to change our mouse cursor to be this new game object, which we just created, and we're going to set is editing to false. So this will essentially remove all other components, including this sprite component. That way we just have an empty game object with only this component, which is the level editor controls attached to it. So now if we go back in and we start placing some blocks and then we hit escape, we escape out of that and we enter into this mode. And we have one more problem, which is, hey, this thing is still selected. So we would have to do that, and that's kind of annoying. And also, when we go back into this and hit this, these are all selected still. So a couple things. First of all, let's do this. This one will be easy. We'll say public void clear selected. And this will simply go, and let's copy this actually, and say clear selected, and just paste it into here. So this will clear all the selected game objects. And then what we'll say is if we are editing, we will clear selected if selected objects dot size does not equal 0. We clear them, and then we just update the sprite position. That will fix that first bug that we saw. So now if we go back in, we place a few objects, we hit escape, we have those selected. And then if we hit this, all of a sudden those are uncleared. But we don't have this problem fixed, which is if we escape, this is still selected. That is kind of hacky the way I did this, but it works. We'll stick with it. Let's just go into menu item. And then what we can do is we can simply say inside of our update loop, if window.keyListener.isKey pressed, and then we'll just take in key event.vk escape. So we're just going to literally check for it inside here. We'll just say is selected equals false. And that should take care of everything. So then if we are placing and then we escape, it changes it down here too for all the blocks. A little bit hacky, I'm going to admit, but it works, and sometimes you're just getting around to whatever works. Now triangles, that's the last part we have to get to. Right now this doesn't work at all. How do we check and see if a triangle does have a collision? Well, there's this thing called barycentric coordinates, which you can use, and they basically do some fancy math where we can tell if a point is inside a triangle very easily, which I will leave a link to in the description if you want to read more about it and see the exact method that I use. I'm literally just going to copy in the method that I use, and there's a link to the GitHub if you guys want to copy it as well, that you can copy into our Raycast method, because it's pretty cool. It's pretty complex. So let's go into our triangle bounds or back down to our Raycast method, wherever it is. Okay, there we go. And then I'm just going to copy this. This is the barycentric coordinate. We do have to implement one function, which is called dot. This just computes a dot product. If you're not sure what a dot product is, it's some vector math that basically returns the angle between two vectors. So yeah, it's really simple. It's just v1.x times v2.x plus v1.y times v2.y. It's all the dot product is, and this is essentially the angle between those two vectors. That's the only thing that we have to do. In terms of everything else, this will be in the link to the GitHub. You can find this file and then just copy all this into your code. But this will return our correctly computed function to see whether we have a point inside a triangle. So then if we go and, well, it's not going to do anything because we don't have is selected doing anything in here. Let's uncomment this real quick. So I'm going to say uncomment. And then we'll say if is selected. Then we will do this and this. And then we'll just say g2.setStroke constants dot thickline. I'm going to import this real quick. And then we'll reset the stroke down here, set stroke constants dot line. And that should be good. And then if we redo this one more time, now if it's selected, we should see it change. So if we go back in, and you can see that's working, but these are drawing in the wrong place. And that is because we do have to transform these ones according to their the camera position. So I'm just gonna tab all this stuff out, make it a little bit nicer because this will get complicated. And then what I'm gonna do is I'm literally just gonna subtract camera position.x from all the x's. So we'll do get scene.camera.position.x and subtract the camera position.y for all the y's. And that's going to take a little bit, so I'm just going to skip over me copying and pasting all this stuff. You guys can feel free to follow along. All right, with that done now, we can just go back into our scene, and now if we do this, it should work correctly. And you can multi-select and do all that good stuff. And if we go into here, go back into edit mode, it switches out. This is good. This sets up the basis of what we will need in order to move the object. Since we can now keep track of which objects are selected, we can now actually move them once the players start pressing the different controls and stuff. But this tutorial has gone on for a little bit too long. I am going to cover that in the next tutorial, which should be one of the last ones. We just have this and then state changes for when they fly through portals and stuff like that. That about covers it for this tutorial. I hope you guys like this. If you did, please hit like and subscribe, and don't forget to hit the bell, and I'll see you guys in the next one. Thanks. See ya.